What I'd like to explain now is this little test setup we have here. We have a radio from a 2002 Volkswagen, and we have our real-time analyzer, which we already discussed, and the CleanSweep DSP processor. I've taken the CleanSweep calibration disc and put it in the head unit and put track 1 on, which is a multi-tone that contains equal energy at third octave centers. So at each one of the bands that the RTA displays, there's equal energy in the track that's on this CD. So a perfect radio would output a straight line like we used earlier to describe the function of the RTA. Let's take a look at what this Volkswagen radio actually does with this response. I have the DSP processor defeated to show you the natural response of the radio. The signal's going from this radio into the DSP unit and then right out into the RTA. So the output of the CleanSweep is connected directly into the input of the RTA. What we see here is a pretty typical OEM frequency response curve. Instead of that nice flat line, which is our target, what we see is that there is a significant decrease in energy below about 40 hertz. They do this typically to protect factory speaker systems from damage when the user gets a little too aggressive with the volume control. So by rolling that energy off, they actually limit excursion. Then there's a big notch in the mid-range, probably designed to conceal some peaky behavior in the mid-range speakers that are used in the car. And then a broad rise in the treble range, again designed to conceal a flaw probably in the frequency response of the factory speakers. That probably compensates for a lack of high frequency extension in the factory speakers. If we were to apply a perfect loudspeaker system and drive it with this signal, okay, we would be listening to a very uneven frequency response represented by the RTA here. The factory systems apply this equalization almost always now. It's become very cost effective to employ a small DSP processor inside these head units, and they have some free horsepower left over to apply these kind of corrections. So they take advantage of that, and because they want to give their customer a better listening experience with the limited resources they have in terms of the speaker quality they use and the locations that they choose and all that good stuff. The problem is when we put in a really nice pair of speakers in the car and a nice subwoofer, we're dealing with a curve that fundamentally starts from a bad place. And if we don't do something to address that and to correct it, then we're essentially limited in what we can do. What we want is this flat response that you see right here. And the flat response you see is the fact that the CleanSweep processor has just gone out of its defeat mode, and as you can see now, its correction is active. In case you don't believe me that this thing just happened on its own, what we'll do is we'll do a complete calibration to show you how you can calibrate a CleanSweep when it's installed in the vehicle. We connect the 4 channel outputs of this head unit, which is simply a high-powered head unit in this application, to the 4 high-level inputs on the CleanSweep. We insert the calibration disc. We turn the volume of the head unit up to approximately 3/4 level, anywhere from 2/3 to 3/4 level. It's not critical exactly where you are in that range. You just want to choose an arbitrary point. You don't want to go all the way up because we want to make sure this radio is not clipping. And you don't want to go too low on the OEM volume because then we might not have enough signal to get a clean result on the other end. The more signal we have going into the CleanSweep, the better our result is going to be. Okay, so we've established our 3/4 volume level at this point. And in order to calibrate the CleanSweep, you use a precision tool like this bent paper clip I have here, and you press the calibrate button. The lights will start to change in color and do some things for a few seconds. What's happening here is the first thing the CleanSweep is doing is analyzing the level of the signal coming out of this radio, because the signal could be really low level or it could be really high level. The CleanSweep automatically detects the level of the signal and sets its input sensitivity automatically. And then, once that sensitivity is set, it converts that analog signal into digital audio with 24-bit resolution. At that point, the CleanSweep analyzes the frequency response in the digital domain and applies 30 bands of equalization per channel in order to correct that frequency response. And as you can see, while I was talking, the unit went through its whole cycle in about 22 seconds. And the result is 4 green lights, which means you've achieved a successful calibration, and you can see the result on the screen right here. This is the CleanSweep's master volume control here. As we can see, we also have a signal that remains linear when we adjust volume, which is very important for good aftermarket results. Whenever you're dealing with a head unit that has full range outputs, the implementation is very straightforward and very simple, like in this case with this Volkswagen head unit. This unit simply spits out 4 equalized full range signals. It's important to note also that the signals coming out of this radio are different in the front and in the rear. I'll give you an example. I'm going to defeat the DSP unit so we can once again look at the frequency response. This happens to be a front channel output on this head unit. I'm going to change the connection to the analyzer to one of the rear channels. And as you can see, the curve is completely different, actually more aggressively equalized in the rear channels. So one of the nice things about this DSP unit is that it's able to analyze each channel independently and correct it independently back to flat. That way you have a nice flat front and rear signal. So whenever you have full range signals that are equalized, the CleanSweep's ability to correct that is absolutely vital if you want to create a good sounding aftermarket system using the OEM head unit.